This is ridiculous. 2 to the 5th is a big number. 2 to the 7th is even larger. And 2 to the 9th is even larger than that. And as much as I hate multiplying two large numbers, I hate dividing by large numbers even more. So you know the drill. We're going to find something smart to do here. Now this is a pretty complicated problem. What I like to do on complicated problems is focus on little pieces of the problem. I'm going to focus on this piece right here. So maybe if I can solve this little piece, 2 to the 5th times 2 to the 7th, that'll make the problem easier. So we'll start with 2 to the 5th times 2 to the 7th. Now I'll go ahead and write 2 to the 5th out. That's the product of 5 2's. 2 times 2 times 2 times 2 times 2. And when we multiply by 2 to the 7th, that means we multiply in 7 more 2's. Well, this is interesting. I started with 5 2's. I multiplied in 7 more 2's. That means I have a total of just 5 plus 7 2's. So this is just 2 to the 5 plus 7. And of course, that's just 2 to the 12th. So we just added up the exponents. Well, there's nothing special about 2, 5, and 7 here. If I start with a to the x times a to the y, well, that's the product of xa's and ya's. So if I take xa's and put them together with ya's, I get a total of x plus y a's. Now, it's important here that the bases are the same. If I had started up here with 2 to the 5th times 3 to the 7th, I'm just going to have to multiply that out, or probably go get a calculator. But when the bases are the same like this, and I'm multiplying, it means I can just add the exponents. So let's go back to our original problem here. We see that this is, using our new rule, this is 2 to the 5th plus 7th divided by 2 to the 9th. So that simplifies to just 2 to the 12th divided by 2 to the 9th. Well, we are able to handle the product of two powers that have the same base. Here we have the quotient of two powers that have the same base. Let's take a closer look at that. So we're going to start off with 2 to the 12th divided by 2 to the 9th. Now, of course, I really don't like dividing by these huge numbers. So, what do we know that we can divide by 2 to the 9th easily? Well, I can divide 0 by 2 to the 9th. That's really easy. That's just 0. It's not going to help us here. Let's see. What else can I divide by 2 to the 9th? Well, I can divide 2 to the 9th by 2 to the 9th. You take a number that's not 0 and divide it by itself, you get 1. So if I get 2 to the 9th over here, then I could divide this out. Well, I can take the 2 to the 12th and use the rule that we just saw for multiplying two powers, except I'm going to use it backwards. I'm going to break up 2 to the 12th. I'm going to break up that 12 into a 3 and a 9. This 2 to the 3 plus 9, 3 plus 9 is just 12. Well, that's just 2 cubed times 2 to the 9th. And all I'm doing there is using the rule that we just discovered for multiplying two numbers with the same base. And now this is something we can handle. 2 to the 9th divided by 2 to the 9th, that's just 1. So this goes away. 2 to the 3rd times 1 is just 2 to the 3rd. Now let's take a closer look at what we really did here. It's like we started with 12 2's, and we want to divide by 9 2's. We canceled out 9 of the 12 2's, and we're left with just 3. So let's see what that looks like in general. Imagine we started off with a to the x, and we were dividing by a to the y. And of course, a is not 0 because no dividing by 0. Now, what we want to do here is we want to have an a to the y over here that we can cancel out with the a to the y we're dividing by. So what we do is we take our a to the x and we break that into a to the x minus y times a to the y. Because when you multiply these two, we know what we do. We add the exponents, and that'll give us x, because the two y's there are cancel. And now this is something we can handle. A to the y divided by a to the y, that's just 1. And we're left with a to the x minus y. Now again, it's very important here that the bases are the same. That's why we're able to do this, why we're able to do this cancellation. What we do here is we start with xa's, we're dividing out y of the a's, and we're left with x minus y of the a's. So now we can take this, back to our original problem and finish up. Using the rule we just discovered, this is 2 to the 12 minus 9, which is 2 cubed. And that's a power of 2 we can handle. 2 times 2 times 2. That is 8, and we are done.